Okay, Algebra 2 students, today we're going to practice solving with rational exponents. So in this example, we've got 5 times the quantity of q minus 2 raised to the fractional exponent of 3/4, and it all equals 40. I know this is touching, so you can't really tell it's a 4. Let me fix that. Okay, that didn't help much. Anyways, okay, so if you don't remember how to go from a fractional exponent to a radical, and from a radical to a fractional exponent, you need to review that desperately, because you're not going to be able to move on to these higher level problems if you don't understand that yet. So there is a video going over radicals. You've got it in your book. Utilize the tools that are given to you. Okay, so first thing to do, I need this factor all by itself. So I've got 5 on the outside of it being multiplied to it. So to get it to the other side, do the opposite, which is divide. So divide both sides by 5, and I am left with q minus 2 times 3/4 equals 8. Okay. Now, I'm going to do this one at a time. I'm going to deal with the numerator first, then the denominator, and this is why. A lot of you have an easier time, of course, doing one step at a time. So what I'm going to do, in order to get rid of that numerator, I need it to equal 1. So what do you multiply times 3 to equal 1? The reciprocal, which is 1/3. Okay? And what I do to one side, I must do to the other. Okay, but again, we still have a fractional exponent. What does that mean? Fractional exponents just means you can turn it into a radical. The denominator is the index, and the numerator stays as that base's exponent. If you don't know what these terms are, you really need to go back and memorize what these terms are. Make flashcards, talk out loud, write it down, whatever helps you. You've got to learn your learning style in order to be able to succeed in a lot of areas in life. So these two cancel out. So I'm left with q minus 2 raised to the fractional exponent of 1/4. Okay? Equals, I'm going to change this into a radical. So it will become the cubed root of 8, which equals 2. Because remember what the index means? It just means if I take a number and multiply it to itself this many times, which in this example is 3, I will get this. So if I take the number 2, multiply it to itself 3 times, I get 8. 2 times 2 is 4, times 2 is 8. Okay? So my answer here is 2. Okay? One thing to remember, you may be thinking, why am I not setting it to positive negative? You only have to do that with an even index. Okay? And this is why. If I have negative 2 times itself times 3 times, negative 2 times negative 2 is 4, times negative 2 is negative 8. It does not equal positive 8. So with the odd indices, you can only have what this radicand is actually set to. But even powers, because if I have, say, the 4th root of 16, that would have to be set to positive negative if I'm creating it. Because if I have negative 2 times itself 4 times, I get negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is 16. Same with positive 2, you get 16. So it could be both. So that's why positive indices, you don't need it. Even you do. Okay, now we are at q minus 2 raised to the 1/4 equals 2. How do we get rid of that 1/4? What times 1/4 equals 1? 4. Okay, so we're going to raise it to 4, because remember, an exponent raised to another exponent, you just multiply them together. Oh, let me do this so we don't forget. Raised to the 4th, what you do to one side, you must do to the other. These cancel out, so we are left with q minus 2 raised to the 1st power, so that's itself, so equals up to raised to the 4th power, 16, we just did that. Now, get q by itself. Excuse me. Add 2, and you get q equals 18. There's your answer.